And now, without further ado, I will call to the stage our amazing speaker, Luca Mezzalira. Luca Mezzalira is a principal solutions architect at AWS and an international speaker and author. Over the past 18 years, he's mastered software architectures from front-end to the cloud, providing the right solutions for the context of the job at hand. Luca, welcome, and thank you very much for being here with us. The stage will be all yours, so I will be out, and you can start your presentation.
Thank you very much, Ricardo. So, hi everyone. I hope that you had a great lunch and you are ready to talk about micro-frontends, one of my favorite topics. So today I want to share a different angle of micro-frontends. In the last few years, if you followed me, I always talk about the why embracing micro-frontends and the right way to do so. This time we see the topic from the other way around. Because in reality, we need to bear in mind that there is no compression algorithm for experience. That's what our CEO in Amazon is saying, and Jesse, and I fully agree. So basically, I try to summarize in the what happened to me in the last 7 years and collect all a bunch of nuggets of tech that I would like to share with you and see if you will find useful at the end. Okay, so my name is Luca. I'm a principal architect in AWS, an international speaker and O'Reilly author. And we start without any further interruption. So micro-frontends, I would like to start first from the benefits because it's not all, let's say, I don't want to talk only on the anti-patterns today. So benefits are definitely incremental upgrades. We know that with micro-frontends, because we can slice an application in multiple and independent chunks, we can deploy them independently. That means also we can migrate a monolithic architecture towards micro-frontends incrementally, so we don't have to go in a big bang fashion. The other thing is when we have micro-frontends all available, we can change them and update them at their own speed, so without, let's say, coordinating with massively with other teams. There is also a concept of decentralization that brought on the table. So if before we were used to have tech leaders that were deciding everything in our front-end application, now we can have skin on the game. And therefore, every team will follow certain guardrails that are defined by the tech leadership, but they will take the decision for specific topics. So for instance, if they want to implement a design pattern or a library, they should have the freedom to do so. There is also a concept of team cognitive load. If before you were used to learn a single page application, for instance, end to end, and being able to put your hands in every part of the application, now because you are responsible for just a chunk of the application, you start to have less cognitive load to take into account, and therefore you can cover end to end a specific part. Also, when you onboard new joiners, you will be able to allow them contributing faster because they don't have to understand every single part of the code, but they just need to understand the business domain and how you have designed that. So quite a few benefits over there. Last but not least, scaling. So thanks to micro-frontends, but in general distributed architectures, you have the possibility to not only scale the technology, but also the organization. If designed well, and highlight if designed well, a distributed system will allow you to scale your organization massively, and therefore you can create multiple independent teams that are taking care about a portion of the application. Okay, so those are the benefits, but let's start to talk of what we have learned in the last few years about micro-frontends that usually are, let's say, how people are failing the implementation of micro-frontends. So I would like just to give you a warning. The first one is I call it a yin and a yang, or micro-frontends and components. We need to understand what is the difference, because often I've seen people that are changing this name during a conversation. So they're saying components, but they meant micro-frontends and vice versa. Instead, in my opinion, there are some clear meanings. Let's start with the first one, a component. So let's take probably the most common component that we are going to have in a web application, a button. So in a button, usually what we have by default is label. And that's how the API would look like. So you have exposed a label property and you basically set the property. Then one day the product team asks you, okay, but we want to add this same component in another website, and we want also to have the possibility to add or not an icon. So you start to add now also the part, the icon that you want to have. So you can have just the label and then, or the label and the icon. And then few months later, you want to change the border color because that is what was requested, and then different rollover animation, and then localization is and internationalization is in the mix. So you need to do auto sizing for the component dimension, and finally you want also to enable or disable the button based on a specific state. It maybe are in a form, you want to disable till all the mandatory fields are filled. As you can see here, if you imagine to design this component, you start to have a bunch of properties that you expose, and someone else is driving how the button should look like. So when you have a very large interface with a lot of APIs, usually you are in front of something that is controlled by the outside and therefore a component. So when the domain is not owned inside this specific entity, that means you are looking into a component. If we look at instead of micro-frontends, this is the definition that I used to say. They are a technical representation of a business subdomain, if you're familiar with domain-driven design. And they allow independent implementation with same or different technology. They minimize the code share, and they're owned by a single team. What I want to focus today is on those two key principles. So they are a technical representation of a business subdomain. So usually a micro-frontend looks not at the problem from a technical perspective, but from a business perspective. When you work with domain-driven design, when you work in distributed system, you tend to slice and design your architecture based on your organization structure, and that is the Conway's law. That usually is how people have designed software. Obviously, you can also reverse the thing. So first you design the architecture, and then you apply that inside the company. So you reorganize the company. But in this case, a micro-frontend is just a portion of a subdomain, so a portion of an application. The other thing is an independent artifact. Therefore, you can deploy that independently without coordination with other teams. That doesn't mean you will never ever have to coordinate with other teams. There are certain situations where maybe you have to, but it's more, let's say, it's definitely not that the day-to-day is more an exception. So if we look at the micro-frontend, then usually what you have is a well-encapsulated business domain where it's independent. We just said that. It's domain aware, so it knows exactly how to run. It might have some properties that are shared, but really not many, as the button that we shared before, or a component that contains a lot of information that are leaked into the container. That defines input and output. Usually micro-frontends allows you to define very clearly what are the inputs and the output, and usually through an event-driven approach. And finally, are not extensible. Therefore, if you think about a button, you can extend and compose by multiple parts, but a micro-frontend usually, because it's domain aware, it's very specific on a part, and therefore on a part of the application, and therefore extending that will bring basically that domain into another part of the application, and usually is not what you're looking for. So when you find yourself in a situation like this, where you have a very fine-grained division of your application, you might be in front of a lot of distributed components more than micro-frontends. So be aware of that. The takeaway for the first anti-pattern is, are you designing micro-frontends or components? Because both of them a different way to be to fit inside the software development lifecycle, to be distributed, and often components require a lot of coordination and a lot of let's say sharing between teams and external dependencies that you don't want to have in distributed system. The second anti-pattern is called the Hydra of Lerna, and is the basically the concept of multi-frameworks approach, right? So in this case, I heard several times micro-frontends are great because you can mix and match frameworks. There are even companies that are optimizing the design for allowing the developers to have more than two frameworks, sometimes two, but sometimes more than two frameworks. My question to you is, how many UI libraries or frameworks are you using in a single page application? Monolithic one. I hope the answer is one, because it means that you care about performances. And Micro-Frontends is no exception here. You are not designing an architecture for scaling, compromising the user experience. Otherwise, it's a big problem, right? So multi-framework approach might make sense, but in a specific period of time and for a short period of time. So when you're dealing, for instance, with legacy system, you want to migrate this legacy system towards a micro-frontend one. So usually, because the nature of micro-frontends that are independent and we can incrementally deploy them, we can use this nature and have micro-frontends living alongside the legacy system for a while. The same thing when you are migrating to a new version of your UI framework or library. So for instance, if you're moving from Angular 2 to a more recent version of Angular, you can do that iteratively. You don't have to go in a big bang fashion. And finally, when there are acquisitions, is another thing that I have seen with some customers, that they acquire a company, they want to immediately get value out of it, and they want to have a way to combine under the same umbrella their IP, so the software that they have created. In this case, as you can see, you might have a multi-framework approach. Once again, is for specific reason, and moreover, it's not forever. It's not that you're optimizing for that. So you have a transition phase towards a micro-frontends application. Therefore, when you think about multi-frameworks, use them when appropriate, don't optimize your architecture for that. The next one is called the Swiss Army knife. And Swiss Army knife is, as you can see, I'm not, let's say, too young, and my white beard testify probably, but I'm in love with Unix mindset, where you do one program, it will do well, they combine very well with others. So it's for me, it's a mantra. So when, for instance, imagine this scenario, you have a micro-frontends application, greenfield, you start straight away with micro-frontends. So you have a micro-frontend A that is loaded inside a container, then another two that are loaded inside another container. Because are two different domains, you are mixing them together visually, but they are two different teams that are working with that. So if you want to communicate between them, you decide to go with an event emitter, so they can exchange information between one and the other. And finally, you use a local storage for storing the token that you have, session token that you have. Okay, so suddenly a new requirement came in, and is a legacy editor that was made by a completely different technology, and is something that rewriting from scratch, it will take months, if not years, to do so. So the first intention usually I have seen people doing is, in this case, they take the legacy editor, they wrap it in a frame, they use the frame as the iframe as a micro-frontend, if you want, and squeeze inside the same container. The problem is the container is optimized for micro-frontends, not for this thing. So in this case, if you implement straight away in this way, the legacy editor and the container have to change the way how they communicate. So instead of using the API that you design, you need to use post messages for defining this part. That is far to be ideal. So one possibility that we have learned as a way to fix these kind of problems is using an anti-corruption layer. An anti-corruption layer is wrapping the iframe in this case, in this example, and is the one that is sanitizing the communication between the application shell, so the container of the entire micro-frontends, and the legacy editor. So in this case, the anti-corruption layer is communicating with the legacy editor in post message, but is translated that in whatever APIs you want. That is great because you are aligning your decision and your architecture decision in one go. So you have just a tiny layer that is preventing that you need to change the code in the application shell, that is the main container of micro-frontend. And moreover, is ready for the future. The moment that you have rewritten completely the legacy editor, you can swap the architecture design, the anti-corruption layer, and then you can load the new legacy editor written with micro-frontends, and everything will work straight away as long as the API remain the same. So I think it's a great way for handling these kind of problems that often are occurring, especially when you are migrating applications. So try to spare the application shell code base on adding code that you know is going to be thrown away at some point, and use an anti-corruption layer instead that is basically sanitizing the communication with the application shell. The next anti-pattern that I have seen, this is not probably only for micro-frontends, but in general, is the dependency cell, or do you really need that external dependencies? So in micro-frontends, as we said, we tend to reduce how much we are sharing, because sharing is creating external dependencies, and external dependencies for distributed system are complicated to handle. I give you an example. So imagine that you have a bunch of functionalities, not necessarily a design system, but a bunch of functionality you want to abstract in a core library, because when you abstract, you always have utils library or core library, stuff like that. So a core library now is version 1.1.0, fresh developed, perfectly tested, great to be integrated, and now you start to integrate it. Unfortunately, though, a few months later, you add new functionalities. Not breaking changes on the API, but just new functionalities. So now you have an update of your library, core library. And the question for me is, are you happy with a situation like that, where one micro-frontend updated the version of the library, the core library, and the others not? The answer might be yes or no. Depends from the context, right? But in reality, when you think about distributed system, you might find this situation very often, especially when you have external dependencies. Therefore, you need to understand if the governance you have in place is the right one or not. The other example that I want to show you is another one that I experienced firsthand, unfortunately. That is when you have a core library and then you start to integrate that. Suddenly there is a team that says, okay, the core library does 80% of what I need, but not everything. So I want something more. So the core library 1.1.0 released, all the micro-frontends are implementing correctly, but the team responsible for micro-frontend B is creating the core library extended. That is basically based on version 1.1.0, but then everything is fine. First release, all good, all aligned, great. Then obviously time pass and you need to look into your backlog and continue to deliver feature and new functionalities. So now suddenly we have a new situation. We have the version 2.1.0, so major change, therefore breaking change in the API, and you need to cope up with that. So the core extended library can immediately straight away use the 2.1.0. Probably not, because if there is a breaking change on the API, they need to change also the way how we're using their application, or sorry, their extended library. So the problem, as you can see, is that this kind of, let's say, inheritance between libraries, it might scale badly, especially in distributed system. So when you have one shared library and one extended library that is based on the shared library, you might get away with one team handling that. But when you work at scale, that can be a real problem. So my suggestion here is trying to decouple the library. So more than extending, try to compose, because composition definitely is a great way for handling that. We know for a while, but unfortunately, when we try to create a library, sometimes we forget that. And I really want to avoid this kind of situation that I have seen more than once in my career. So always choose composition over inheritance. That is the takeaway. The next one, return ticket please, or unidirectional data flow at the rescue. Now, there are many implementations of micro-frontends. There are frameworks, libraries, there are plugins, whatever. Let's say, common, despite the framework you're going to use, there is a very common thing that especially people that start for the first time work with micro-frontends, they fall into. And it's this situation. Imagine you have a container and the remote, so a host and the remote. The host is loading the remote, and that's what you expect. But sometimes you have the possibility to share bidirectionally, either in your own framework, either micro-frontends framework are doing that, and therefore the host is sharing stuff with a remote. But the problem is when there are multiple remotes, that is very likely in a distributed system. One thing that we have learned in the past is that back in 2014, roughly, if you are familiar with Flux, that was one of the first state management with this, let's say, with this approach, not the first state management in general for JavaScript, but one of the first state management this approach, introduced the concept of unidirectional data flow. So there were four, let's say, entities, action, dispatcher, store, view, that they had their own action and their duties. And the flow of the information was always unidirectional. That increase drastically the throughput of developers and reduce drastically the amount of bugs in production, because now it's getting very simple because everyone has his own duty to make, and also you know that after the action there is a dispatcher and so on and so forth. So you know exactly where to debug. The other thing is this model was used also, and is used also in MVI, or model view intent. That is another architecture that was present and is still present in JavaScript. Cycle.js, for instance, if you're familiar with that, was one of the first framework that I've seen working with that. But also nowadays with native Android development, you often see MVI. So this way where a user is interacting, dispatching an action, the intent is captured for the user intent is captured, is sent an input to the model is changing the state and is loading a new state to the view, and the view is updating what the user is seeing on the screen. So as you can see, the unidirectional data flow is not just a nice thing to have, is something that it will help you drastically in your development. Therefore, with Micro-Frontends, please bear in mind this, because what we have learned is that it's easier to debug and is less prone to errors. And that is exactly what we want to do, especially when we work with distributed architectures. So multiple teams working together for the same outcome. Therefore, try to avoid as much as possible bidirectional sharing unless it's strictly needed. So that is the takeaway for this antipod. Oh, this one is one of my favorites. This one I have seen very more or less every 2 engagements with customers is something that I've seen it. So relax is just code, or avoid organizational coupling. So in this case, one thing that I've seen very often is people starting with Micro-Frontends. First thing that they think is, okay, I decouple the view and I create a nice global state. So every view is deploying independently, but the global state is shared across all the system. That's a big problem, because it's not a problem only on the architecture. Yes, it might work, technically speaking, it works. But the problem is design time coupling. Design time coupling is a concept coming from microservices, and basically tells you that if I'm responsible for Micro-Frontend A and another team is responsible for Micro-Frontend B, they have to test each other, make sure that they don't break whatever update they make in the global state, in the shared state. And that's exactly where you don't want to be when you are in a distributed system, because when you are in a distributed system, you might risk that you lose more time fixing this problem than anything else. So the idea is, if you're using an event emitter, you can have a highly aligned and loosely coupled entities. So Micro-Frontend A dispatch an event, wherever is the consumer will take it or not. And it doesn't matter for the producer, because in reality, it's just bubbling an event inside an event emitter. That's it. Usually, what I suggest in this case is try to always look into independent entities. Micro-Frontends should have their own state management. They shouldn't share state management. They can share other information like token, for instance, stuff like that, but definitely not a state management, because otherwise you are coupling your design, and every time you need to make sure that everything is working, and you don't want to test everything in production every time to make sure that it doesn't blow up in front of the user. So bear in mind, strong encapsulation, embrace loosely coupled, but highly aligned Micro-Frontends. Last but not least is this one. So what I call the less armored API, or multiple Micro-Frontends that are calling the same endpoint. So imagine this situation. I have 4 Micro-Frontends in the same view, and then the 2 at the bottom are calling exactly the same API. That, on the surface, shouldn't be a problem. 2 different teams calling the same API. Unfortunately, the context might change, and I can show you how. Imagine that those 2 Micro-Frontends are calling the same API. So usually, if you have a Micro-Frontends, not always, but often, you have also a distributed system, usually developed with microservices. So microservices expose the endpoint through an API gateway. Though this specific example is running inside an intranet or authenticated users, let's call it that way. So every time there is a call, you pass the bearer token, and then the authorization service is validating at the application gateway level. So now the authorization service has to handle 2 calls. Now, finally, you arrive to the API 1, but distributed system, right? So the API 1, instead of having a response straight away, is calling other APIs in order to retrieve that. Now, you have currently 2 codes for every of those single boxes. Therefore, you need to design microservices that are able to cope with that load without any problem. Now, if there are 2 requests, 10 requests per second, not a problem. What if there are hundreds of thousands or millions? That is a problem. It's not only a problem because you are, let's say, putting strain into the backend, but it's also because it's going to cost you way more. Instead, you can avoid that with simple refactor of your code. So possible solutions here. The first one is, if you have 2 microfrontends calling exactly the same API, the question for me is, are you sure are 2 microfrontends? Maybe if you go back to the whiteboard, you can see that in reality are as unique microfrontend that can be handled by one team. The other option is, if you assess that you really need to have 2 separated entities, treat them as components. You can have a microfrontend that is making perform the call to the endpoint. We know the microfrontends own the domain, so fine. And then they inject the result into the components. And in that case, you just have always one call, and you can handle that properly also on the backend. So it's important that when you take these kind of architectural decisions, you try to understand end-to-end the impact of them. Often, because we are dealing only on our domain, it doesn't mean we need to ignore the rest of the system. We need to always keep an eye on how the things are working, how other teams are dealing with that, and understand how to prevent, let's say, potential issues to the entire system. As usual, I would like to wrap up this talk in this way. So architecture is always a trade-off. If they are telling you, or if you're thinking that, let's say, there is right or wrong in architecture, unfortunately, it's not the case. We can achieve the same outcome in multiple ways. The context should derive which is the right way to do that, based on what we are gaining and what we are losing for specific decisions. What we have seen today are definitely things that I recommend to double check 3 times before you are going to change your decision, because I have seen the impact of those anti-patterns across large organization and large system, and it might be a problem. So that's it for me. I hope that you enjoyed the talk. Happy to answer your question. If you have any question for me after, you can see my email at the bottom of this slide. Thank you very much.
Thank you very much, Luca. It was super cool. Thank you for preparing this presentation. So nice. I have a few. First of all, let's check Slido if we have any questions. So far in Slido, we don't have any questions for you, which is not a problem, because they can also the audience can also send a message directly from Hopin. Yeah. And in case they want to contact you, there's your contacts there. So people, if you want to ask him a direct question, please use Hopin.